Good day, I am RNJB Kilit from BSc 4A and I'm going to share my insights for Lesson 4, specifically purlins, as part of the activity of Compre 2 or Comprehensive Examination in Design and Construction. Regarding purlins, I will provide the introduction and the design problems. Purlin is a lightweight horizontal beam or bar that is used for structural support in roofing. In addition to providing support, purlins also increase a building's resistance to heavy winds. Purlins are a key component to the secondary frame of commercial, residential, and industrial buildings. There are different types of metal purlins that are characterized by their shapes. The most common include C-purlin and Z-purlin. C-purlins provide structural support for beams required for walls and flooring. In addition to roofing, C-purlins are often used for structural support in walls and as floor joists. The advantages of C-purlins include the ability to span length, no side drilling or cutting required, and it also assures straightness and durability. Z-purlins are horizontal beams that form the roof and wall joists of a building shell structure. The shape of the purlins helps in overlapping the joint, which makes it stronger and sturdier than C-purlins. They are often used on large-scale structures because of their strength. The advantages of Z-purlins include superior strength. Purlins can also be overlapped and save material by reducing purlin height. Here are the steps that are usually used in solving the analysis and design problems. Una ay alamin natin yung load, na usually ay given as pressure. Then, we will convert it to distributed load. Yung value na nakuha natin from distributed load will be used to determine the maximum moment. And then the maximum moment will be used to identify the maximum stress. For problem number 1, a light gray channel is used as a purlin of a truss whose top chord is sloped at 15 degrees from the horizontal. So in this problem, yung light gray channel ang ginamit as purlins ng truss na kung saan yung top chord niya has a slope of 15 degrees from the horizontal. Given are the properties of channel section, which includes the modulus of elasticity, its weight per unit length, its span, and also naka-indicate din na gumamit ng sag rod at the center of the span. Regarding loads, the total dead load and live load were given, assuming that these loads pass through the center of the channel. Lastly, the allowable stresses. And then we are going to find the maximum spacing of purlins due to dead load and live load. Kapag mag-a-analyze tayo ng purlins, i-consider natin yung normal and tangential component in reference on roof surface. Kasi kung mapapansin natin sa problem din, nakaslope yung roof. So nakaslope din yung purlins. Kaya lang, yung dead load and live load na nag-a-act sa purlin ay downward. Kaya kailangan natin i-separate yon into component na nakaayon nga sa normal and tangential component ng roof surface. Para makuha na natin yung pressure sa normal axis, total load, which is 950 Pascal plus 1,200 Pascal, multiply to the cosine of 15 degrees. So, the normal pressure is 2,076.741 Pascal. Then, for the tangential axis, total load multiply to the sine of 15 degrees. Then, the answer is 556.461 Pascal. So, na-separate na natin into the respective components yung pressure. After that, i-convert natin yung pressure into distributed load. Para makuha natin yung distributed load, i-multiply lang natin yung pressure sa spacing. Therefore, distributed load is equal to pressure times spacing. In the formula shown, omega refers to the distributed load, P is the pressure, and then S is the spacing of purlins. So, sa normal component, 2,076.741 Pascal multiplied by the spacing of the purlins, since yun yung hinahanap, leave it as variable S. Therefore, it will be our equation 1 for the normal component. Same method as to tangential component. And then the next step is to calculate the maximum moment. In order to calculate this, omega multiplied by the L squared divided by 8 para sa normal component and divided by 32 para sa tangential. Omega refers to the distributed load and L is the spacing of trusses. Bakit nga ba iba-iba yung value ng denominator? It is because of the sagrad. Ang main purpose ng sagrad ay para suportahan yung purlins para hindi mag-bend masyado. Kaya iba-iba yung possible na maging value ng denominator kasi depende siya sa position ng sagrad tsaka sa axis na to. Pwede naman na hindi maglagay ng sagrads, pwedeng sa midspan, and pwede rin sa middle thirds. The image shown in the screen are all values that can be used depending on the position and location of sagrads. After substituting the values, meron na tayong equation 2 for both normal and tangential component. So, pagkatapos nun, computin na natin yung maximum stress. Para makuha yung maximum stress, i-divide lang natin yung maximum moment sa section modulus. F refers to the maximum stress, while M is the maximum moment and S is the section modulus. So, yung equation 2, which is the maximum moment, i-substitute lang natin sa maximum stress equation para makuha natin yung equation 3. From the equation 3 of the normal component, the maximum stress is equal to the product of 72.698 and distributed load along the normal axis. Di ba mayroon na tayong nakuha na equation ng distributed load kanina? Yun yung equation 1. So, isa-substitute lang natin yung equation 1 sa equation 3 para makuha yung maximum stress in terms of spacing. Ganun lang din yung gagawin sa tangential component. Finally, para makompute natin yung spacing, gagamitin natin yung formula ng interaction value. Kapag sinabing interaction value, yun yung ratio ng actual stress sa allowable stress. And for a structure to be considered safe, kailangan ang value niya ay less than or equal to 1. Substituting all the values computed, therefore the maximum spacing of purlins due to dead load and live load is 0.56 meters. For problem number 2, it is similar to the first problem. The only difference is that we're going to consider wind load, given as pressure with coefficient at windward and leeward side. Then, for the allowable stress, 1/3 in increase is allowed. And we are going to find the maximum spacing of purlins due to dead load, live load, and wind load on the windward side. We also need to find the maximum spacing of purlins due to dead load, live load, and wind load on leeward side. Before solving the problem, we must first understand the action of the wind load. In the figure shown, yung wind load, mag-a-act lang talaga siya sa normal axis of roof surface or purlins. Therefore, ang mababago lang na value sa atin ay yung sa normal component. So, we can conclude na yung forces na nag-a-act sa normal axis ay dead load, live load, and wind load, while sa tangential component, dead load and live load lang. Sa windward side, makikita natin na yung action ng wind load ay downward. This means na nakaka-add ng stress yung wind load sa purlins. Therefore, para makuha natin yung total pressure, i-add lang natin yung wind load multiplied by its coefficient. After that, i-convert natin yung pressure into distributed load. So, kagaya lang din ng kanina. Para makuha natin yung distributed load, i-multiply lang natin yung pressure sa spacing. Since yung spacing nga yung hinahanap, leave it as variable s. Therefore, we will arrive at our equation 1 for both normal and tangential component. So, similar process lang din sa pagkuha ng maximum moment and maximum stress as to problem number 1. Using the interaction value, 171.912 multiplied by the spacing over the sum of 110 megapascal and 1/3 of 110 megapascal plus 45.364 multiplied by the spacing over the sum of 110 megapascal and 1/3 of it is less than or equal to 1. So, as stated in the problem, the combination of wind load, dead load, and live load permits the addition of allowable stress by 1/3 of it. Therefore, the maximum spacing of purlins due to dead load, live load, and wind load on the windward side is 0.675 meter. For problem number 2.2, we are going to consider the leeward side. So, as I have said earlier, yung wind load ay nag-a-act lang sa normal axis of the roof or purlin surface. Sa leeward side, makikita natin na yung action ng wind load ay upward. So this means na binabawasan pa pala ng wind load yung stress na nararanasan ng purlins sa leeward side. So para makuha natin yung total pressure, i-subtract lang natin yung wind load sa